Hello everyone. In today's class, we are going to learn about the very important topics from the chapter chemical kinetics. In that, I am having the derivations. There are two derivations, very important derivations. First is zero order reaction and first order reaction. After that, we will have that zero order half life time period. Okay, that kind of derivations also there. Okay, first we are going to solve this main derivations. Okay, first I am going to tell about the zero order reaction. Okay, it is very easy derivation. You can easily solve it by knowing. Okay, let us solve now. First, if it is zero reaction, you have to do one thing, that reactant to product you have to write directly. Okay, in examination you have to write this much. After that I am going to show the steps. Okay, here reactant gives product, tending to product. Okay, after that what you have to do is we know that concentration d of R divided by dt equal to, this is minus, you can also call this as rate equal to minus d of, this is of concentration of R, means concentration of R means concentration of reactant. Okay, dr by dt equal to k into R raised to 0 we are having. Okay, here you have to clearly observe how we can do this. You leave these things. Okay, you consider only these two things. Here what we can do is you send this dt to that side. Okay, after sending, here you should see that here concentration of reactant raised to 0 it is. We know that basic thing, if anything raised to 0 is what is the value of that? That is 1. Okay, 1 means 1. Here also concentration of reactant raised to 0 is there, so it is a value 1. Okay, here you have to take it as 1. It becomes k into 1 k. Okay, here d of concentration of R equal to minus, you send this side k, this is k into dt, you have to send this side, it becomes k into dt. Okay, this is the equation we are getting now. After that, here we have to integrate this to get the value of here in this derivation we have to find the value of k. Okay, so to find k, first we have to integrate this one. Okay, here integration of d of concentration of reactant equal to, this is minus k, this is constant, so I am putting this outside. Okay, here integration of dt, only I have to do dt. Here dt means here we are having constant, so how we can write integration of dr is only r, that is concentration of reactant. Okay, equal to, yeah, minus k you write as it is. After that integration of dt is t, integration of dx is what? X, like that only. Integration of dt is t. After that integration of dt, we are getting t. Here we will have to write the concentration of integration. Okay, in the integration chapter in maths we use concentration of integration as c. Okay, that is concentration of integration. Okay, now here what we are using, constant of integration we use to that. Okay, now here we have to use the constant of integration as I. Okay, you have to use that one. Okay, this is the concentration of integration. After that, in place of t we have to put 0 at t equal to 0. Okay, and R, concentration of reactant equal to R naught, means R naught means what? Initial concentration of the reactant. Okay, that is also same like that only, but here is R naught means that is initial concentration. Okay, after that you have to substitute these two things in this equation. Okay, in this first equation means second equation we have to put these values. After substituting these values, here R means R naught we have to take, that is initial concentration of reactant, you have to take that equal to minus k, in place of t you have to put 0. Okay, plus I you have to write as it is. After that, here you make it simplify. we get it is R naught equal to I we get. Okay, you consider this as equation number 3. Here what you have to do is you have to substitute this equation again in this one, again in this second equation, then we get the answer. Okay, this is I equal to R naught, means initial concentration of reactant. We get the value of what I know, integration constant. We have to put that in this second equation. Put equation 3 into, okay, after putting this is equation 2, you write this one as it is, equal to minus kt plus, in place of I we have to put this one, that becomes R naught. After that what we have to do is we have to make simplify for this k. We are finding the value of k. Okay, you send this k to this side, this R to that side, concentration of R to that side. Okay, here kt equal to this becomes R naught minus this concentration of reactant that side. Here this is kt. If I take this to this side, it becomes positive because here is negative. This is positive, so if you send that side, it becomes negative. After that, here we get it is k equal to R naught minus concentration of reactant divided by T below that. This is the expression for zero order reaction. This was very easy. Okay, now we are going to learn about first order reaction. This is also same previous one, like previous one only. This is also same, very simple it is. You can easily do this one. First you consider reactant to product. After that again rate equal to minus d of concentration of R divided by dt equal to k into concentration of reactant. In previous zero order reaction we have taken that R raised to 0. Okay, this is, that was a zero order reaction, so we had taken there 0. Now this is first order reaction, so here we have to take 1. If I take here 1, this will remain R only, concentration of reactant, this will remain like this only. In that anything raised to 0, it becomes 1, so that was become 1. Now R raised to 1, so you send this R to this side, this dt to that side, same they are like that only. Here d concentration of R divided by equal to k into dt. Okay, after this the procedure is same only. Here you have to integrate both sides. If I integrate both sides, I will directly integrate here only. You know that what is dx by x, integration of dx by x matlab means it is what, 1 by x into dx. It means that log of x we get, log of x in or ln of x you can call. Here we take ln only. In integration maths we take log. Now we are taking ln only. So it becomes ln of x, means x, what is the value of x here? That is concentration of reactant equal to integration of you put this outside, this is minus, no sorry, this here is minus, it is minus k. Here it becomes again t plus constant of integration. Okay, after that you can consider directly this equation as first equation. After that again here we have to substitute the t as 0 or as r naught. Okay, substitute at t equal to 0 concentration of R equal to R naught. If we substitute these values in that, this becomes ln of concentration of R naught equal to minus kt kt in place of t put 0 plus constant integration you write as it is. After that you make simplify, it becomes ln of r naught equal to I. This is considered second equation. Okay, here what you have to do is you have to put this equation in this one first equation, that becomes ln of r equal to minus kt plus in place of I what we have substituted ln of r naught. Ln of r naught, very easy. After that we have to make simplify, we have to send this one to that side and this to this side. Here it is minus, so it becomes plus. After taking this side, it is kt equal to ln of initial concentration of reactant minus ln of concentration of reactant. Here before getting the value of k, what we can do, we can simplify this like maths. We know that what is the property, this is here a basic property, that is log a minus log b is log a by b. Okay, we can write this like that only. This becomes ln of r naught divided by concentration of r equal to, here it is kt. Clear? Kt equal to ln r naught divided by r. After that here it is in the form of ln, we want in the form of log to make it simplify. To get the in the form of log, what we have to do, we have to multiply 2.303 into log, you can write now, of r naught divided by this concentration of r. Here we want for k, so we have to send this t to this one, this side, it becomes here divided by, here it is, we got the value of k. Okay friends, these are the two derivations from the chapter chemical kinetics, very important for the exam point. Okay friends, thank you.